morning. Let us introduce ourselves. My name is Rachel Narwastu Andamaputri.
And I'm Aditya Septian Maulana.
And we are from Senior High School 1 Kudus. On this occasion, this morning, we will present to all of you our research entitled Aquara, Aquaponics and Organic Planting. In the 2023 Indonesia Science Project Olympiad, concerning the use of limited agricultural land in densely populated urban areas, based on IoT to become modern eco-farming solution. In 2015, the Ministry of Health of the Republic of Indonesia, or Kemenkes, estimated that 41% or more than half of Indonesian population live in urban areas. With the development of a large population in Indonesia, there will happen agricultural land, which will become a serious problem in the future and increase the risk of a food crisis, especially for the lower middle class in Indonesia.
In need for food as a primary need, the risk of poverty levels in society will result in hunger and high social inequality. Based on data from the Central Statistics Agency, or BPS, in September 2022, the percentage of poor people was recorded at 9.57%, an increase compared to March of the same year. This happened because of the process of economic recovery after the COVID-19 pandemic and threat of a global food crisis. The higher the percentage of the poor people, the more chance there will be. Therefore, we created a tool called Aquara as a solution to overcome the problem of the global food crisis by producing food independently. That is by eco-farming method using aquaponics media, which where limited space can use to cultivate fish and plants together. However, aquaponics has its drawback, namely the difference in needs between pH and nutrients needed by fish and plants in one medium, so that monitoring and control of the water content can be identified.
Aquara can be controlled by the system automatically and periodically by utilizing the Internet of Things, or IoT, in its operation and reducing the role of humans in controlling aquaponics. This tool works with the help of the pooling application, which can be connected wirelessly with a smartphone or a computer. It is hoped that by utilizing this application, all people can access and use Bing as a reliable monitoring system, so that all data collected by the sensor and the existing system can be connected to the Node MCU ESP3266 microcontroller.
The location of our research was carried out of the rooftop of Senior High School 1 Kudus, which is located at 41 Pramuka Street, Kudus. Our research time starts in November 2022 and ends in February 2023. In conducting this research, the type of research we use is: first, library research, by using library materials such as a research report from previous researchers. Second, field research, by conducting a question and answer session with farmers who apply the hydroponic cultivation system. And we will also conduct a question and answer session with the agro-technology lecturer at the Faculty of Agriculture, Muria Kudus University, about cultivating the aquaponics system. The data collection applied is called experiment research. We make changes to our give special treatment to the variable examined. In this research, we also involve parties who help us in the process of conducting research. The first is Mr. Hafid Shifaunur as our project supervisor. The second is Mrs. Puji Asuti as our writing supervisor. The third is Mrs. Shofiato Ulya as our English supervisor. Next is Mr. No, who always helps and guides us in this project. And the last one is Ardan Krisyuva as our electronic supervisor.
The research phase that we carry out begins with the product planning. In the second stage, we carry out design research, such on the product design that we will implement, the systems for the product that we will use, and the tools and the materials that we will use. In the third stage, we are planning the application systems that we will use. In the fourth stage, we conducted product trials accompanied by sensor trials, such as a temperature sensor, humidity sensor, pH sensor, and water turbidity sensor. And in the last stage, we conducted data analysis and discussion.
According to our result and discussion after conducting trials and data collection, Aquara can be a reliable monitoring tool because it has a small percentage of error and is close to the value of the SNE, Indonesian National Standard Measuring Instrument. According to the data we got during the trial, it showed the following result. The DHT11 sensor gets temperature result close to the thermometer gauge with an average error of 0.62% and humidity close to the hygrometer gauge with an average error of 2.47%. The pH sensor approaches the pH meter gauge with an average error of 2.09%. And the turbidity sensor, the water shows a range of 3000, which indicates that the water in the pool is cloudy. If the pH sensor in aquaponics shows a number below 7 or 8, the pump will automatically pump new water into the pond, and if it shows a number above 7, then the pump will stop working. The following is the working mechanism of Aquara by monitoring variables and displaying data obtained through Blink. And if the pH in the water is acidic or alkaline, the water pump will automatically work to neutralize the pH level in the water.
The conclusions from the study is that Aquara is an effective and efficient solution in aquaponic cultivation systems, especially in automation and water monitoring. Aquara can be monitor important variables in the growth and development of fish and plants automatically via the Blink application.
Our hope is that Aquara can be developed by editing variables such as TDS sensor and can be mass-produced with the hope that general public can use Aquara in the aquaponic system. Finally, we realized that this research is far from perfect.
Our criticism and suggestions will be beneficial for our results.
Thank you. God bless you.